I need you to notice the new setup of the graphs. Now, is it still XY? Yeah. But you'll notice a new scale on the x-axis. It's not going 1, 2, 3, 4 anymore. All right. When we graph sine and cosine or any version of it, we're going to graph in radians on the x-axis. All right. So this is in radians on the x-axis. Okay. So you see your boy pi, you see your boy 2 pi, negative 2 pi. That's all in radians. We'll always graph it. Okay. The y-axis will go by 1s, 2s, whatever the scale is. All right. So help me fill in this chart first before we start actually plotting points and seeing what this graph looks like. We are talking about sine now. So what coordinate am I going to look for you to pluck off the unit circle? The y coordinate. All right, so here we go. At 0 degrees. At 0 degrees. Anybody remember what the whole coordinate was at 0 degrees? 1, 0, right? And we're doing sine, so what's the sine of 0? What coordinate did you just tell me you're going to pluck off every time? The y coordinate. So the sine of 0 is 0. Let's keep going. 30 degrees. What's the y coordinate? 30 degrees. 30 degrees. Hasn't been that long. 1/2, right? All right, 1/2. What is the y coordinate at 60 now? Okay, radical 3 over 2. Now we're at 90. It usually is 0, 1, right? But I need the y coordinate, so the sine of 90, 1. Are we okay on those values? Because now they're going to start repeating themselves. Now I go to 120. I have no idea what the coordinate is, but I know the reference angle for 120 is what? 60, so it's going to be radical 3 over 2. But hold on. What quadrant am I entering now? Quadrant 2. What do I know about sine in quadrant 2? It is positive. Get off the phones. 150. What's my reference angle? 30, so it's going to be 1/2. Still positive? Yep, I'm still in the second quadrant. Let's go to 180, another quadrantal angle. -1, 0. So what's my sine value at 180? 0, the y coordinate. Okay, we're going to start seeing repetition again. 210, reference angle for 210. 30, right? 1/2, but now we got to pay attention. Why negative? Now we're getting into the third quadrant. Yes, so that should be -1/2 we're going to plot. Okay, what about 240 reference angle? 60, so it'll be radical 3 over 2, but yep. Okay, 270, back on the quadrantal angle. That's 0, -1. So what's the sine? -1, you guys are good. And then let's finish this up strong. 300 reference angle. 60, so it's going to be radical 3 over 2, but negative again. We're in the fourth quadrant for sine. How about 330? 1/2, but negative. And then we're back to the beginning at 360. Also known as 0 degrees. What was my y coordinate? 0. All right. So there are all the values. Now, how do I plot them? Ready? All these go by 30s, or pi over 6s. All right, since we're graphing in radians, all these go by 30s. So you don't have to worry about skipping over anything. So at 0, what was my y value? 0. So that's where we're going to start the graph, right at 0, 0. Okay, let's graph some more points. At pi over 6, 30 degrees, what was my value? 1/2, so I'm going to go up to 1/2. At pi over 6, or excuse me, pi over 3, 60 degrees. Radical 3 over 2, what's that as a decimal so I can kind of be in the ballpark when I graph it? Radical 3 over 2, about 0.87 everyone's getting? Okay, so here about 0.87, ballpark it. Now next one, which is pi over 2. What was my value at pi over 2? Okay, so I graph 1. Can you guys take it from here? Now it's going to start repeating itself. Radical 3 over 2, which you told me was about 0.87, 1/2, 0, and now I go into the negative y value. So go ahead. Please just plot the points. Plot the points. Do not connect them yet. Looking good, everybody, on their papers. Nice. Okay, this is called the sine curve, not the sine line or the sine heartbeat monitor. All right, I say that because it's got to be a smooth curve here. Be gentle. Smooth curve, no peaks and valleys here. Smooth curve. It shouldn't look, here's what I mean by the heart monitor at the hospital. It shouldn't look like that. All right, smooth curve. And we're gonna stay there for a second because we got a lot of new vocabulary I'm gonna throw at you here today. Can you guys tell me a couple questions? What's the max value here? 1. Yep. When I talk max and min, I'm talking y values. Okay. What's the minimum value? -1. Nice. So using that, what would our range be? Bringing up a term from last year. Range, are those your x or your y values? Y values, all right? So what's your y values go, because it's not all real numbers here. It goes from what to what? 1 to -1. Does it include -1? Does it include +1? Okay, so I'm going to write it in a notation you are familiar with from last year. If it includes those, should I put parentheses or brackets? Anybody remember from last year? You guys are right. Brackets. All right, so when I write the range, -1, 1. Unless you guys prefer the inequalities. You do, really? Really? Wow. Okay. That's I'm shocked, but that's fine. I'll accept either, by the way. So if you guys want to do -1 y to +1, that's fine too. All right. I just figured you'd want to do the shorter version, but hey, I'm fine with both. We'll do both if you want. Maybe you'll change your mind by the end of class. I don't know. We'll see. All right, I'm going to introduce 2 new words to you right now. Okay, 2 new words. The period. Okay, the period. Let me describe it and we'll write it down. The period is how long it takes to make one full cycle on the x-axis. On the x-axis, how long it takes to make one full cycle. You guys right now are looking at one complete cycle of the sine curve for me. All right, you're looking at one complete cycle of this sine curve. So on the x-axis right here, how long did it take? And don't do this. Don't go 1, 2, 3, 4, 5, 6 units because we're not going by ones anymore. These are in radians now. So how long is it from here to here to make this full sine curve? Yeah, 2 pi. The period is 2 pi. And guys, that's where we're going to stay for at least today and tomorrow. All right, that the period, how long it takes, is 2 pi. Last vocab word I'm going to introduce is the amplitude. That is how high it goes. How high this graph goes. How high does it go? Up to 1. So the amplitude, +1. And you just maybe want to make a note right here. We'll talk about it more in a second. Amplitude, always positive. It's always a positive value. Now, is anybody thinking, what's the deal with the left side? Yeah, what's the deal with the left side? And I'm not expecting you to be responsible for this, but sine is what's called a periodic function. It means it just continuously repeats. So if I kept going past 2 pi, you know what I would see? That curve again. So guess what I'm going to see on this side? It's going to start repeating again. All right. So if we quickly just graph this, this is going to start. So at 1, 2, 3 right here, it's going to be down at -1, back to 0, back up to 1, back to 0. That's what I would see if I kept graphing to the left side. A constant, after every 2 pi, it will start repeating itself again. All right. After every 2 pi, it'll start repeating itself. Questions there? Because we're still not ready to move on. Good news. Good news. I'm not going to have you do all these values every time. I am only going to do what I'm going to call the critical values. Here is what I refer to as the critical values. 0, pi over 2, pi, 3 pi over 2, and 2 pi. What did we call those last unit? 180, 90, 270, 0, 360. On the line, quadrantal angles. Okay? Here's where we're going to end this before we do another graph. Where does sine start? At 0. Sine starts at 0. Then it goes where? 2. Well, I don't want you to remember these middle ones. I want you to remember only the critical values here, the quadrantal angles. Starts at 0, goes to the... No, okay. Yes, 1 in this case, but what is 1? That's the maximum. So sine starts at 0, goes to the maximum, then goes where? Here we go. Starts at 0, goes to the maximum, then goes to 0. Then goes to its minimum, whatever the minimum is. It may not be -1. And then finishes at... I only want you to remember those 5 concepts. Starts where? 0, then goes to the maximum, to 0, minimum, back to 0. That's all I need you to remember for sine. Okay, that's all I... Don't remember specific numbers other than 0. Just remember max, min, and the zeros. We all good? Because now I'm going to change things on you. Again, everyone, this was y equals sine x. Look at what I'm going to have you graph now. What's the difference between this graph, and don't make it complicated. What's the difference between this graph and the one that you just graphed? There's a darn 4 in there. That's it. That's all I needed. There's a 4 in there. How is the 4 going to affect your graph? Ready to go? Before we do, I'll always give you an interval to graph over. 0 to 2 pi, meaning I don't care one bit about the negative side. Don't worry about it at all. I'm just graphing everything from 0 to 2 pi. Are you ready here? Ready to go? Okay, where's sine start? There you go. Okay, here we go, 0. And guys, I don't care about the values in between anymore. Then it travels to where? The max. It was 1, but that 4 in front now, that tells me the new max is 4, okay? The number out in front will affect your max and your min. So now it's at pi over 2, it's at 4. So it starts at 0, goes to the max, then goes where? Back to 0. That doesn't affect anything. Then it goes to the minimum, which now is, what's my minimum? -4. And ends at, okay? Those are the only critical values you need to remember. 0. up to the max, 0 down to the min, end at 0. Not worried about the numbers and the values in between the quadrantal angles. Not worried about it. Okay, a couple questions for you. What's the period? How long did it take to make one full sine curve? Okay, 2 pi, and that's going to be my answer until Monday. Range. -4 to 4, and again, however you want to write that. You can go -4 to 4 with the brackets, or you could go -4 less than or equal to y less than or equal to 4. Whatever floats your boat. Ooh, new question here. What's the difference between your max and your min values? Well, what was my max value? Max value, 4. What was my minimum value? -4. Difference means to do what with these two? Subtract them. So what is the difference between 4 and -4? How far are they apart? And that's positive 8 units. And if you want to count on your graph, count on your graph. How many units is it between -4 and 4? 8 units. Whoa, we're getting crazy over there, huh? Calm it down. Not here. What quadrants is sine positive? Okay, and I'm going to show you this because I don't know, probably none of you will think it's neat, but I think it's amazing. Quadrants 1 and 2, that goes from 0 to 180, right? Check me on that, 0 to 180, quadrants 1 and 2. What do you notice from your graph from 0 to 180? It's above, it's in the positive y direction, right? There you go. Here's quadrant 1, everybody. Here's quadrant 2, 3, 4. What do you notice about sine in quadrants 3 and 4? Yeah, that's what the graph says. That's what the graph says, all right? It's starting to match up a little bit. All right, sorry. I got jacked up on that one. Okay, over what interval is sine increasing? Oh, calm down, calm down. And I'm serious. Can anybody come up here and circle a portion of this graph where it's increasing for me? Oh, you actually want me to? Yeah, legit. Circle a portion of that graph for me where it's increasing. Oh, just one. Okay. Everyone agree that's increasing? All right, thanks. How do I write that interval now? And I'm looking for the x's here. From 0 to pi over 2. Now, here's the thing though. Ready? Right? Is it increasing right at 0? Nope. Is it increasing right at pi over 2? Nope. So how am I going to write this? 2 ways. You guys that do the brackets or parentheses, I'm going to put parentheses here because it's not increasing at 0 and it's not increasing at pi over 2. You guys that want to do the inequalities, 0 less than, now I'm going to put an x here because we're talking about the x-axis, to pi over 2. I don't care which way you use, just those are the same things, just pick away. You sure you don't want to start going to the parentheses or the brackets? Okay. Yes, JT. I'm not done yet, boss. I'm not done yet. Thank you, though. Everybody good here? All right, JT, go ahead, spew it out. I got to put that in there, too. Yeah, nice job. Nice. Guys are on fire. So what was it, 3 pi over 2 to 2 pi? Yep. Or again, you can write it. Why do you guys like this better? All right. I'm just asking. Just asking. I've accepted the fact I'm not going to change your opinion, and I'm good with it. I'm good with myself now. All right. Okay, this one might be a little tricky. What line splits the minimum and the maximum values in half? So go back here. You guys got your maximum value and your minimum value. What line is halfway in between those? That's what I'm asking here. What line? Yeah. What line is halfway in between those? The x-axis? Everyone, the x-axis is halfway in between. We don't write the x-axis in here. That's elementary-ish, middle schoolish. Anybody remember the equation for the x-axis? Y equals 0, yep. That cuts it right in half. Y equals 0. Okay. I'm going to add, hey, E, F, G, H. Can I add in a part H? Yeah, I can because I teach the class. How about the amplitude? We answered period in part A. How about the amplitude? How high does it go? What? Whoa. 4. Haven't we seen that 4 somewhere? Where did we originally see the 4? There it is. That will always tell us what the amplitude is, whatever number is out in front. Okay, whatever number is out in front will tell us what the amplitude is. And it's always what, though? Positive. Okay, it's always positive. All right, I'm going to change things up here because I want to stick with the sine curve before we go cosine. Can you guys go to the last problem in the notes? I believe it's number 5 for me. All right, sine curve. What's different now? Ooh, all right, we're going to talk about that. What effect does the negative have on it? All right, it's the sine curve. Where does it start? Okay, boom. All right, there you go. Until tomorrow. Watch what I throw at you tomorrow. It won't start at 0. Then it usually goes where? To the maximum, right? What would the maximum be in this one? 2, right? But here you go. Here's where the negative comes in. Do you guys remember last year at all? What happened to a graph when you applied a negative to it? Anything. Well, I don't know what that is. Down 2. No, that's if I put -2 at the end. That's what we're doing tomorrow, though. No. The negative flips it over the x-axis. All right? So now, instead of traveling to its maximum, it's going to go where? To its minimum of -2. Take a look, everybody. -2. Because it'll flip. Because usually, hey, it doesn't go up to the maximum, but now it's flipping over. Then it travels where? 0. The negative's not going to affect that. And then usually at this point, we go down the minimum, but we're flipping it because of the negative. So now we'll go up to 2. And where do we always finish sine for now? At 0. And I have 2 questions here before we go to cosine. Do you guys see that now? The negative flips it. All right. What's my period here? What's the period? Still 2 pi. Look, it's taken 2 pi to make that nice sine curve we always know. Ooh, ready to go here. What is the amplitude? 2. It's always positive. So hey, think about it this way. If there's a negative number out in front, you guys remember absolute values? Take the absolute value of it. Okay, if there's a negative number out front, take the absolute value because amplitude is always positive. How do we feel about sine? One last time. Where does it start? Then it goes to its max, then travels back to its, and then to its minimum and finishes at, okay, because cosine's not going to do the same thing. Okay, cosine's not going to do the same thing. It's going to have a totally different pattern to it. You ready to find that pattern, though? You all right back there, boss? You sure? All right. It's like you need a little, come back there, a little forearm shiver right underneath the chin. Some chin music back there. All right, ready for cosine. Gaha. Thanks, bud. Appreciate it. Or maybe just come up there, back there, Jason. Big roundhouse. I can get that thing high, trust me. Little stretch, be ready to go. All right, you ready for cosine now? Now I don't want the y coordinates from you. I want what coordinates? X coordinates. Here we go. X coordinates from you. 0 degrees. I don't have to draw this again. What's my x coordinate at 0 degrees? Ooh, so cosine's going to start at 1 now, not 0. All right. All right, here we go. 30 degrees. What was the x coordinate? Radical 3 over 2. How about 60 degrees? 1/2. At 90, what was the x coordinate? Ooh, 0. 120, what's my reference angle? 60, so 1/2, but I'm now entering the second quadrant. Negative for cosine. Like all this ties together, huh? 150. Radical 3 over 2, but negative 180. What's the x coordinate at 180? Negative 1. 210. Reference angle. 30-degree reference angle, right? So radical 3 over 2. We're now entering the third quadrant. Keep it positive or negative for cosine? Negative in the third. And you guys are just starting, they're starting to repeat. All right, so I got negative 1/2. Ooh, 270. What's the x coordinate at 270? 0. 300. 1/2, but positive or negative. You're in the fourth now with cosine. Good, keep it positive. Radical 3 over 2. And we end back up at 1. All right, let's get a graph. Let's see what this beast looks like. Starts at not 0, but 1. Okay, start graphing the points now. What did we say radical 3 over 2 was? About 0.87, okay. 1/2, 0, negative 1/2, negative 0.87, negative 1. Go ahead, finish off those points, and let's see what the cosine curve looks like. Okay, and then most of you already connected it, and that's fine. Just make sure it's a smooth curve. What do you think is going to happen on the left side? It's going to start repeating, so it looks like I got 2 U's up there. Or V's, I don't know, whatever letter you want. Don't start with me. Look all right? Okay. It looked like you were judging my curves. Sure. Okay, now this has a new pattern now. Sine started at 0, but where's a cosine curve going to start? Ooh, I don't like that number. What is 1, though? The max. Cosine. Good. All right, you're bringing it home now. Good job. You're redeeming yourself. Cosine, ready? Starts at its max, then goes to 0, goes down to its minimum, 0, finishes at its max. So it goes max to 0 to minimum to 0. And again, Don't think you got to memorize this. We're going to do so many of these graphs and versions of them. We'll know it already. All right. All right. Couple questions. I want to do the questions first before I graph. 1/2 cosine x. What's the amplitude? Yeah, it's the number out front. 1/2. It's going to go up and down to 1/2. The period, how long do you think it's going to take? Yep, 2 pi. We'll change it up in a couple days, but stick there now. What's the max value going to be? 1? In this one? 1/2. Yep. And the minimum? It's going to go down to? Yep, up and always up and down in the same number here for now, until I shift it tomorrow. So that would mean my range, if that's my min and my max, my range, -1/2 less than, should I put the or equal to? Does it include -1/2? Yep. Y, 1/2. Or again, we talked brackets if you want. And what's the difference between the minimum and the maximum? -1/2 minus -1/2. What's that difference? -1? 1, right? They're 1 apart. Think you guys can graph it on your own? Okay, ready? Think about it. Where's cosine start? I know we're new at this one. At the max. What's the max? So it'll start at 1/2. Then it goes to where? 0. So pi over 2, 0. Then it goes to its minimum, right? What's the minimum of this graph? -1/2. Back to 0. And it ends at the max. What quadrants is it negative? Cosine 2n. And does that match up with my graph? Ready? 2 to 3, negative. Darn right. Where's it decreasing? Anybody want to circle this? Where's it decreasing? Anybody decreasing? Going? There's only one spot. Unlike sine, there's only one spot here.
Wait, how is it one spot?
Circle what you're going to circle.
So then you do it.
Oh, a challenge accepted. All right.
It's decreasing. Oh, wait, go back.
Is it voice recognition now I don't know about? Just go back.
Wait, it's here. It's not there either. Oh yeah, but you said no when I was about to circle it. Yeah.
How about there? Everybody good? How about right there? Okay, explain to me the x values then. From 0 to pi. And again, when we talk about it, it's not decreasing at 0 and it's not decreasing at pi, so I don't put the or equal to there. Or parentheses if you prefer the parentheses. All right. I don't feel too comfortable right now letting you go on your own, so I'm going to graph one more sine and cosine with you. So go to the homework for me. Can we graph, let's graph y equals 3 sine x first. All right, the second one I'm asking you to graph. Y equals 3 sine x. And I'm just going to do it on this one up here. Y equals 3 sine x. So everyone tell me something about sine where it starts. Okay. Then it usually goes to its max. What's the max on that one? Yep. And then it goes to the zeros. Then where? Whatever the minimum is, and that in this case, -3. And then where's sine n? At 0. And then you can just repeat it when you have a second on the other side. Okay? Can you, after you're done doing that, can you flip the page and let's go to a cosine one for me? We'll do a class decision on the next page. Which cosine one do we want to graph? Preferably not cosine x because we've done that one, but 4, 2.5. Cosine x, you didn't want to throw a negative in there? You want to do -5.5? Okay, you got it, everyone. I'll do my best. My graph only goes up to 4, but I'll do my best. Okay, where's cosine start? At its max. What's the max here? 5.5, but what's the negative tell you? Take that 5.5 and flip it over to -5.5. Then where does it travel to? Cosine goes to 0 next. Then usually it goes to its minimum, but we're flipping it, so it'll go to max of 5.5. Then where? 0 and end at its, usually it's max, but we're flipping it, so -5.5 it'll end. What is that? If you want to continue with the graphs, go ahead on the homework or answer some of the multiple choices on the next page. All right, practice at it, practice. Even if you don't do any more graphs, fine, but at least try to get some of those multiple choices done.